Okay, here is the meta randomizer. It's a which dog are you randomizer. Let's watch it real quick here. Which dog are you? What's it going to be? What's it going to be? Oh, a poodle. All right. All right. And then if I tap it, we get a nice restart. Okay. A little different here. Okay. Lhasa Apsa. So you might notice that this is not terribly different from the randomizer you get when you just load up Meta. You can choose to load a new project from a template. 2D randomizer is one. It's not terribly difficult. It's really just about that end state and how we have these extra stickers flying in. However, there are some complications to make that all possible, and we're going to walk through all that. So, quick review of this structure and what's actually in the scene so you know what to mess with. First, we're not analyzing your behavior and matching you to a dog. We are just turning on a sprite sequence that just cycles through just the visibility right here. This indicates a patch has been made in the node graph for it, or the patch editor, as Meta likes to call it. And we have the intro that has visibility toggleable on it, and that's the which dog are you. So this face tracker is just holding these two guys, and they just are visible and then not at different times. Then there's a master holder that kind of has everything else in it except for the audio. The audio is just an M4A. And in the PDF for this, I'll put in the specifications for how you should encode your audio. Meta is very particular about its audio. For some reason, it can't just play an MP3. It goes for maximum compression, smallest file size, so people that don't have like top tier connectivity still get a good experience with an effect. I get it, but they should still have MP3 support. So open up Holder, and in Holder we have stickers, which is the master holder for this stuff. It's a little overdone on my part, but it doesn't hurt anything. There is a visibility setting for stickers that does get toggled and initially is set to not be visible. And then each of these options, these 10 options, are the same structurally. So we'll just look at one because they're all otherwise the same. Each of them has a face tracker in it, and that face tracker holds the actual result that says which dog you are. That's tied to your head. Okay. And then a sticker element for each one. Drill in here. You can kind of see the placeholder for the placement, the bounding box for each, which you can adjust however you like or remove. Just an option. Okay. But there's just a 2D element attached to it. You see each one's got a material assigned to it. And as we drill into this, you'll see that there's just a texture for that material, and you could replace the texture, not even touch the material, and everything would work just fine just with your own new options. But that's all we're really doing, is just toggling the visibility of these options, and that shows you your result. So it's just a randomly chosen option that gets its visibility toggled on. In assets, we see our audio file, the M4A I mentioned earlier, the playback controller for the audio. There's a little gotcha in Meta with audio files if they're just a play once file, and you'll see that in how we deal with the play and the reset node. In textures, we have the resulting texture files. Different from the effect house slightly in that there is a text result, and there is a resultant dog that is cycling through your head in the dog sequence. It's a little bit different. If you look at the two templates, there's a slight difference there. And a little challenge would be to see how to tie in the dog sequence in Effect House, because right now in Effect House, it just cycles through text. So you can drag in or import from computer your sequence or your texture, have it there, and it'll be there in your textures. And then if you wanted, you could just in your material grab the new texture from here that you've brought in. And that would be an easy way to quickly put in your own assets and get going right away. If you have 10 options, you're good to go. Not to skip over the sequence here, animation sequence, just controlling that sprite sheet, the 10 frames and its relationship to the frames per second will give you that sort of speed and kind of chunkiness in the appearance. And that's pretty much it. So it's really just textures I've brought in, which I created with Midjourney. So there's a bit of an ethical concern there. I have not published this myself, and I don't intend to. I think it's probably okay to do so, but I am not a legal expert on this, and I know that it's still kind of an open question of who owns art generated by AI, because it's art generated by the art of others in kind of an amalgam. And I think nobody's, as of this video, which is April 2023, no one's really sure yet ethically what the stance is. So I leave that to your best judgment. If you want to take things as they are and use this as it is for yourself and publish it under your own account, fine by me. Go for it. I think the worst case scenario for something like this is that someone says, oh, you've got to take it down. And you say, okay, and you take it down. I mean, it's not that complicated for this, fortunately. But it's an interesting ethical debate that just is not yet resolved. Okay, let's take a look at the node graph here. So we don't drill into any subgraphs or anything, which is nice about this, but it's a little more complicated than the standard 2D template. So let's zoom in here. Okay, so this is our runtime, so what's always going as soon as you start the effect. And it will just keep ticking through. But you do have an offset node here so that if you were to screen tap, you could set this value to 0. And that runtime, as it's going, will keep ticking up, but it'll start from 0, effectively resetting your effect. You've got a delay, 2 for 2 seconds. So after 2 seconds, this pulse gets sent out. It hits a switch. Okay, and that switch does a couple of things. It hits a knot into this intro. Remember that intro is just the which dog are you? And even though the switch turns on, we're trying to turn this intro off. So we negate that pulse with the not node, and that will turn off the visibility. Okay, this switch gets that turn on pulse, sends out its own pulse here, and a couple of things happen at once. We can tell from these pipes. We get the turn on to dogs, which is our cycling animation sequence. The visibility for that suddenly turns on. And we start our delay of 5 seconds, which means we're going to see this for 5 seconds. Okay. And then that will pulse out to this, turn on the master sticker holder. It also does something interesting here. It sends its own other pulse out to the reset node for sound effects and sends the play. In meta, if you are playing through and you reset and play again, if you've already played this before, it won't play again unless you reset it. So it can be a gotcha. You're like, why won't this play again? Oh, it's because it's not a looping audio and it already played once before. But now in my second turn playing with the effect, it won't play again because you have to reset it. So that happens here. We also send out a pulse to randomly choose between what should be the total range of our option count. Now you see we have 10 options here, but the start and end range is 0 to 9. Why is that? Well, that's kind of a programmer speak, because when we have an array of objects, in other words, we have a group of elements all in a list together that we want to pick from. In arrays, the first element is actually the 0th element, or the not element. Okay, so 0 is actually the first element. Thus, 0 through 9 is 1 through 10. Okay? Whatever comes out of this random choice is going to be a float, meaning it will have a decimal and some numerical representation past it. It won't be a whole number. We want to make it a whole number though, because if we don't, the option sender isn't necessarily going to activate on one of its triggers leading out. It wants a whole number, a whole option to choose from. So we need a rounding tool, and that's where floor comes in. Floor gives you less than or equal to the number it receives, including 0, meaning the first element. So 0 could come out of floor. Floor, if you've never heard the term floor before, it's like hearing round, only less than or equal to instead of greater than or equal to. So out of floor, you'll get 0 up to whatever number it outputs. And in this first option sender, we have options 0 through 4. So 1 through 5. Okay. Also with option center, make sure this value is checked. That means it's active. And if this is not checked, nothing will ever get sent out from these. Okay. So I'm doing the MK like South Park. So bad. Anyway, these are all going to be structurally the same. So we'll drill into these in a minute. You only need to look at one to know what's going on. We'll stay out here for a second to understand the logic of what's happening here. So we get this floored number out here. And if the floored number is 1, then we will have, then this element will trigger right here. Remember, it's because 0 is 1. I know I'm harping on this now and I've repeated myself, but if you're very unfamiliar with this way of thinking about it, it can be confusing. So, but we get 1 out of that. But what happens if we have more than 5 elements to choose from? We have 10. What do? Well, something above 4 could come out of this random range and get floored out. What we could do then is subtract the number of options that we want to skirt past. Okay, which is 5. 0, 1, 2, 3, 4. What if floor is 5? Well, if it's 5, then we get a 5 right here, and we're doing a subtraction. 5, 5 is 0, which gives us our first element in here. And then 6, 7, 8, so forth and so on. The math works out so that it chooses the right option in that sender and bypasses this one. A 6 is never going to match with 0, 1, 2, 3, 4. But 6 minus 5 will get us 1 here. You see? So what if you have 15 options? No problem. Just copy this structure. You want another subtraction node coming out of here. Okay. But this time it should account for the fact that you need to skirt past 10. So you would start your subtraction node with 10 right here. So that way the math always works in your favor. Okay, and now let's take a look at these individual little subgraphs. Let's expand this out. These are all the same structurally. They're referencing their own elements, but they're all the same as far as what they're doing, which is that you've got that pulse coming in, you start your animation, in this case a very fast 0.2 second animation, in which we do a transition for the scaling of the elements. They start effectively at 0 because the x and y axis for them, they're 2D elements, the x and the y axis are 0, and it goes up to 1, which is 100%. So if you were to start this with like 0.2, then it would never be invisible initially. It would just start out very small. Likewise, you could end at point something or 1 point something to under or over scale it from its maximum dimension. And you see it equally affects the scaling of each of those sticker elements. And it has a slight easing effect to it. So instead of a linear motion, it has kind of a little bit of a slightly more interesting movement to it. And if you increase the duration of that, that's more apparent. We also make sure that the option itself, the holder for option 1 in this case, is visible. So you can see all that stuff flying in. And we don't have to, the visibility is always on because we don't have to control the visibility for all this stuff because its master holder is the only thing that needs to have its visibility toggled. Once that's toggled on, the rest are just visible. As long as you're controlling the visibility of that master holder, you don't need to mess with the visibility of the child elements. Okay? And that's it. So not too complicated, just a little bit of an extra bit of logic, really, to think about in the standard 2D randomizer that lets you have a nice, very controllable, very modular way of adjusting your own effect.